Hello, today I'm going to be taking you through what you actually need to know to work with SQL in Golang. I'm going to be covering the main tools and methods that I use on a daily basis as a full stack senior developer. We're going to start off by very quickly looking at SQL Migrations with Goose, which is a Golang library. Very simple to use, and we're going to build our initial databases with this that we'll be interacting with within the tutorial. We're then going to just quickly work on a function to connect to our SQL database. We're going to be using Postgres in this tutorial, but any SQL language will work for this. We'll then create a utility function for keeping the connection alive for longer running applications, which I will go into in greater detail within the tutorial. For this tutorial, the main thing we're going to be working with is SQLX because it has some really nice interactions with struts and maps to be able to make a nicer structure from our Golang code to the database, but we're also going to be looking at the base SQL library and where it's better to use that. We will then move on to using external SQL files and queries. So if you have a SQL command that is hundreds of lines long and you don't want to be muddying up your Golang code with that, we'll be able to put it into an external file and pull it in through the code. We'll then have a look at using variables to interact with the database. So what I mean by this is if you want to pull out a lot of IDs, they don't normally get pulled into a struct. So how do you just pull them out into a variable? And then we're finally going to have a quick look at context and how to add timeouts to your queries. For instance, if you're creating a GIN API and you don't want any of the API endpoints to run longer than 10 seconds, we'll be making a little function to be able to handle that. For starting off, I have made a GitHub repo with some base commands that we're going to be running and everything that you would need to get set up. So just clone this repo, bring it into wherever you want to bring it in on your machine. After you've downloaded it, open it up in whichever IDE you wish to use. For this tutorial, I am going to be using Golang. So to start, I have put this command here if you wish to use it to start a Postgres container within Docker on your machine. You can use any database that you wish to connect to, but if you want to follow along, this command will get it up and running on your machine. I already have it running. If you do not have Docker already, it is literally as simple as going to the Docker install page. There'll be one for macOS, for Windows as well. Choose whichever one you want. It's just to download and install and you will be sorted. You can completely follow along from that point. The first thing we're going to do is we are going to, with whichever SQL client you wish, we are going to set up a connection to this database. If I can find Postgres on the list. If you're following along with me, the username, database and password are just here. And it will be 5432 for the port number. So for the user, just Postgres. For the password, it will be secret. And everything else, let's just do a test connection, which is all working. It will automatically open up a query window for us. If you move back over to the README file, you'll see that I have left this command here for you, which is just creating the database that we are going to work with in this tutorial. If you run that, you will see that it will come up on the right-hand side within the database client. If it does not, just check here. You might have to click it on to get it to show up. We're now going to move over and work with some database migrations to get some initial databases set up. If you come into the terminal, let's cd into the migrations file now, just so that we're in the correct place. You'll see that within this migration folder, I have put 3 files for us. For this tutorial, we're going to be using Goose, which is a SQL migration tool built in Golang and really simple to use. If you have never worked with Goose before, quickly come into this README. You can read a bit more about it if you wish to here. Otherwise, just run brew, install Goose, and you should be good to go for this tutorial. We will be using a makefile to be able to run these commands. It should already be installed on your system, whether you're using Windows or Mac. If not, have a quick look up and it should be simple enough to install if it isn't. It's very, very simple to use. The goose drive, like this is already set up for our local setup that we have with Docker. Otherwise, if you're using something else, you might have to have a look in the documentation to find out what goose drive you need to use and set up your DB string to your database. For this initial setup that we've got here, I have created this one file here that is going to come in and create 2 tables for us. If you've never worked with a migration tool before, they are extremely useful for when you're working with teams and when you're working with live databases. I apologize if you hear all of that squealing in the background. My cat has decided to join us. Yes, but it's very great when you're working in a team because everybody can just share the same code base, come in, run a simple command, and get the database up to the exact point that it is in production very easy on their end. It's also great for when you're doing things like deployment so that you can easily get a database up to whatever you need it to be after a code push. And if anything goes wrong, all you need to do is do a goose down and it will revert it back to the change that it was before this. So if we go back into our, actually we'll do it down here just for everybody. So if you have an IDE, you can press the ups and downs here. Otherwise, just go into your terminal and type in make up, and you will then see that it has done this database migration. If you come over to here, you might have to refresh your databases, but have a look in your publics and your tables and you'll see that we now have 2 databases here, ones that we have just created. So you should be good to go. Let's quickly go over how to do make another migration file. It's very simple. So I have left it so that with the databases that we have set up, this one, the users has an ID and a username, and the to-dos has an ID and a content, but there is no binding between these 2. So we want, with the to-do, we want to add in a new key and saying I want to have a user ID, and that's just to say we can add an email in for the users table. So if you wish to create a new migration tool, I have also left the command for this here. So whatever you wish to call this new file, just replace this initial databases with whatever you want it to be. So we're going to be adding, I'm just going to do it, so add missed fields. Just call it something fields, something that is descriptive for any future person coming in and working on your system. So if we run this, you'll see that Goose will automatically create this file for us, and it will also have all of the comments that it needs to work with it. I am just going to copy in the commands for this to save you having to watch me type, but this is just going to come in and it is going to alter the to-dos table and add a user ID to it, and then it's going to alter the it's going to alter the to-dos table before and add user ID to it, and then it's going to alter the users table and add the email to it. After this bit, if you need to do it down, it's then going to drop those columns. So if you then come back into your make file or down on your terminal, whichever you want, if I now do a make up again, you'll see that has been successful. And if you refresh your database here, you'll see that we now have a email within the users table and a to-dos within the to-dos, or user ID within the to-dos table. If, let's say, we have just deployed this to a live production database and we realize we've done something wrong and we want to revert it, it is then just as simply as going goose down. It will use the GooseDB version table to know where it's at, and it will go down 1 step. So if we now go down, you'll see that it has only reverted the add missed field step. So now the user ID and the email fields have now been replaced. You could then go back in and you could edit this file however you wished to do it, redeploy your changes, go back up again, move back up the next step, and your databases are now up to date with where they want to be. Now that we have our databases all set up, it is time to start working on some Go code. So if we head back to the terminal, let's make sure we cd out of here back to the root, and I'm just going to close down all of these files just so we can get back up the readme again. Within this readme, I have left a few commands just to get us up and started. nice and quick. So if we just do a go mod init, that will set up everything that we need on the go mod side. And I have 3 commands here to install SQLX, which is an extension to the base SQL library. Because we're using Postgres, we are going to bring in the Postgres lib, which is required for data connecting to a Postgres database. And I'm going to put in logrus just because I quite like it as a logging library, and it adds a few nice utilities over the base printer. Let's now create a go main file. So that's go main. And let's quickly add ourselves a quick main func, and just let's bring in log.info. Okay, logrus is going to come in like this, but that's just import that. I like to import it as log. So let's just go log.info. Let's go hello world. There we go. Run that. And we can now see that we're getting hello world, and we are all set up and ready to go. Let's start by making our database connection. We are going to store our Postgres connection in the global context. You'll see exactly why this is later, but it is so that we have an easy access to it in our functions, and we can grab hold of it absolutely anywhere in any other file for the future. I am going to paste in a connection function to save you the pain of watching me painfully type it out, but I will talk this through line by line. You'll see this first line here, we are asking SQLX to open us up a database connection to Postgres. For this, you need to make sure that you are also bringing in the Postgres lib library by just putting in an underscore and then the lib GitHub repo. This is just the libraries that is needed by the internal golang database script to know how to handle that connection. This data source script, you can find this within the make file we have here, because it's the exact same string that we used when connecting with Goose. This will return us a database pool by default, so you don't have to handle any of the connection pooling yourself. This is going to handle that for us. If we get an error, we're going to make this function just return that, and then we are going to save into the global variable state, the global variable that we made, this database pool. We will then simply check that the connection has worked by calling out and pinging out to that database, and if we get any errors, it's going to return it, otherwise it will return nil. So if we just check this now, let's head down into our main, see if there is any errors, and then we can just go if error does not equal now, we can go log dot, let's just go error for now, and just put in the error. So if we run this, we should just see hello world and nothing else. Now that we have the connection to our database, we need a way to retrieve this connection pool. We also want to have a way so that we can reconnect if anything goes wrong to ensure that we keep the connection alive. So I'm going to paste in this next function and then talk through it again. So this function is just going to be called get Postgres pool, and it's what's actually going to be calling this function up here within our actual app. So we will be returning a pointer to our SQLX database, which is this bit up here. These top 3 lines of code here are only ever going to be ran on the first time we run this database. So in instances when this Postgres pool is completely empty, try and connect to Postgres, so call this function. If the error is not nil, we want to then log fatally. We want to say something has gone wrong, completely stop our application, and it's probably going to be that your credentials are wrong. If we have, however, got something within here, we want to just double check, can we connect to it again? If we get back an error, try and connect to Postgres again. Call this function and connect back to Postgres. If the error is still not nil, log an error to say that something has gone wrong, and try and do this entire function again. So it will then come back through, test to see whether you can get it. Otherwise, call this again, and it will keep doing that over and over again, trying to reconnect to that database. So this will just be for if your database provider has gone down very briefly. This will constantly be trying to reconnect to it until it can finally get its connection and get things back rolling again. Right. We are now going to create a function to use this get postgres pool. That's firstly quickly create a user strut, and we are going to make this in a way that it is representing our user database. So you can call these keys whatever you want, but make sure they represent your keys. But this annotation here with DB, you have to make sure that these keys are exactly equal to what is within your database. SQLX behind the scenes uses this to do its mapping. So that's quickly come down here, and I am going to paste in the function that we are going to use this user strut to insert some data into the database. So you will see here that I am using that user strut to create two different users. So we're going to have our Captain Sparkles with an email of Captain Sparkles, and our user Sergeant Sparkles, and we're going to give him the email of Sergeant Sparkles. And to add this to our database, it is as simple as coming in, calling this function to get our Postgres pool. So this is going to return our Postgres pool. For this function here, we're going to use a named exec, which means that we will be using these annotations here to interact with our database nice and simply. So we just have to go insert into users and say, I want you to insert the username as what we have in our user struct down as username. So what this is set to. And I want you to set the email to what email is set to. And for finding those values, I want you to use this user strut slice. You do not have to do anything fancy here. You don't have to do any kind of concatenation to your string. This knows that because you were using these annotations and you were passing in a slice, that it knows to loop over them for us. So if we grab this function, and if we come down to here, log this out now, or get rid of that, and if we just make a new one, which is error, let's do it for us. So insert users with struts, and we run this, we should see still just our hello world and nothing else. So there we go, we saw our hello world. And if we come over to the database here, you'll see that we now have Captain Sparkles in the database and Sergeant Sparkles. So nice and simple and really clean, a really clean way of just inserting data into our database. Now, let's say that you want to add some data into a database, say it's a join database or something, and you don't have a strut that is dealing with that. Say it's a user ID and a group ID, and it's just that join database that you're going to be using. How do you add data to a database of SQLX in that way? So you can also use maps to do this. So let's have a quick go at adding in a few to-dos without any kind of strut data into the database. It's almost exactly the same as what we had before. So I will paste this one in here. So instead, what we do is we make some maps with we make a slice of maps where the key is a string, and you have to have the value of each of these maps as an interface. So it's saying this can be a string, this can be anything, because we don't exactly know what each of these is going to be. So this has to be interface. And for adding this into SQLX, if you do anything other than interface here, this will error. So make sure that that says interface. Again, we're going to be using named exec, getting our Postgres pool, and then we are going to try going insert into to-dos, where the content is equal to this, the user ID is equal to this, and it's going to be mapping it with what these key values are here, and it's going to be using those to-dos to do that. So if we come down here, let's comment this out, and let's have a go with insert. We don't want users again, we want insert to-dos with maps. So let's run this. Here we go. Has happened. We've got our hello world popping up, so everything's happened. Let's go to to-dos, and we can now see that we have our 3 to-dos in the database. Now that we have some data in our database, let's actually work at getting it out. If we head back up to the top of the file, let's add in a struct representation of a to-do. Again, when you're doing this, really double check that your DB annotation exactly lines up with what you have in the database, because SQLX is using that behind the scenes to do this mapping. So if we head back down here, we are going to start by looking at returning multiple things from the database. So let's work on getting multiple to-dos out of the database. Right. For this function, we're going to return an error and a pointer to our to-dos. We're going to start by adding in a variable for a slice of to-dos, and it's very simply get postgres pool dot select, and we pass in a pointer to our to-do slice, and I am using a select query here with an equals any, purely so that I can point out to you that we are passing in a slice of 1 and 2, and SQLX behind the scenes is very nicely for us converting this 1 into 1, 2 for us, so we don't have to handle any weird string concatenation and worrying about the, making sure that we pass that for us. We are then going to come in and we're going to pass out any errors and then the pointer to these to-dos. So let's grab this function and make sure that it works. You can actually see in my bit here that I have already ran this a second ago to make sure that it did work, but we will do it again anyway. So let's go error, and then we can go to-dos, and then equals multiple to-dos. That's quickly grab that, put that above, and comment that out so that we have that for the future. So with these to-dos, we can keep that error there, and I'm going to grab a quick little function, which is this here. So we go, and this little bit here with the formatting, this formatter here is just going to nicely pretty print anything within this to-do strut here. So if I run this function, you will see that we nicely get out each of the to-dos that is on that was in the database, and you can probably hear that my cat is scratching behind me. Now that we have gotten out multiple, let's have a look at getting out a single record. So for this one here, we are instead going to use a struct method just to show how this would generally be used. So we are going to put a method on the user strut of get user, and this is the simplest function we've got so far, that we will simply go out, get the postgres pool, use the command this time of get, make sure that you only use get if a single item is coming out. If you need multiple, use select, and we are simply going to go select all from users where the ID equals the ID that we are passing in. This will grab this user and it is going to map it into our user strut using these DB annotation fields. So now if we come down to here instead, and let's comment this out, and let's just create a user. So let's go user is a user, and we will go into here of ID 1 so we can get Captain Sparkles. And now if we go error equals user get user, and instead of printing out a to do, that's print out this user here. That's run this command, and we should see that we have now got Captain Sparkles out of the database really nice and simply. Let's now take a look at using external SQL files. So let's start off by coming into here and creating a new directory. We will call this SQL templates, and within that, let's go and create a new file. We will call that file get users to-dos .sql. So this is just going to be a very quick SQL command that will go look into our to-dos database, and based on the user ID that is being passed in, we will return it out. Realistically, this is quite a small query and you'd be better off just doing it like we've been using here, but this is more just to show you how to do this. Really, you want to do this if your query is more than, say, 10 or 20 lines. You don't really want that muddying up your Go code. So now that we have this, let's bring in the function to be able to use this. Here we go. Let's move this over here. So let's go through this line by line. So we are going to do a os.read file. So when you're using this, it always looks at the root directory. So it's going to come in the root directory, find SQL templates, and get the get user to do's file that we have just added here. It's then going to try and read this, and it's going to put it into SQL here as a byte slice. If we get any errors, we just want to return that. Then we can, at that point you have brought in the SQL file, and it's exactly the same as when you're doing things like this here. So we just need to get our database pool again. We're going to use a named query here just so that you can see how named queries interact when you're actually querying them. They're slightly different than before. You can't do this nice mapping. You actually have to do this manually, but it's quite a simple step. So with this line here, we're taking this byte slice and turning it into a string so that we get back to a query that golang can use easily. And then we are just passing in another map like what we did before. And we are passing in the user ID that we want to use within this query. So we're using the user ID here, so that will be mapped to here. So whenever we pass into this function, will go into that query and be used to find that. Again, if we have any errors, we just want to return them. And now we need to get it out of the rows. We need to be able to get what has been returned out of the rows. So if we create a to-do slice, we will then start adding it to that. So we just double check, make sure that the rows is not going to be nil. We then, for each row, the rows has an iterator on it. So we get the next row, we create whatever type of value it is. So for here it's a to-do, we make a new variable for that. And we use this rows.struct scan. So it's going to get whatever the next row is, and it's going to map that data through into this to-do, so that this is now a representation of what that data is, which if that has done it successfully, we can then append that onto our to-dos array. So now we have that, we just want to return, we can either return error here, or realistically you can just put nil here because there isn't going to be an error at this point. And then let's just return a pointer to our to-dos. It should then be as simple as us coming down here, coming in, we can comment this out, and we can then go error to-dos and put in this function here, and we'll get Captain Sparkle's to-dos out. So if we copy this, make sure that we're getting the reference to that. This is doing a little squiggly line, just basically letting us know that it's nil. Really, you want to just make sure that there's actually to-dos that's been returned, because we've got some instances where I can return nil, but for this tutorial, we know that it's going to be there. But make sure if you're ever using this type of query in a production environment that you are checking that these to-dos exist before you try printing them or use them. If we now run this, you will see you are now getting out each of the to-dos for Captain Sparkle very nicely. So that is how you use external SQL files. We have been working with struts and maps so far, but what happens if you just want to get something like one field out of the database? We can do this extremely simply by instead of, so here's the function that we're going to use for this. So instead of making a strut, we're just going to make a slice of ints, and it is genuinely as simple as getting our database, doing a select, which we use for getting multiple to-dos out, and then using that int slice as the reference here, so that when we get all of the IDs out of to-dos, it's going to stick that in there. We can then pass this out, and then if we bring this down here instead, we can then just use a normal log for this. So we'll make that out just for now. So let's just go get single field. So let's go error IDs and equals. Let's go get single field Press this in here, and we should just now be able to go log.info, and that's just passing the IDs. With that, if we now run this file, we will see 1, 2, and 3 for each of the to-dos that we have in our database. Now let's take a look at removing items from the database. This one, we are going to be using the base SQL library for this, not SQLX, just because when you're passing in queries like this, there really isn't any need for the power. And the really nice thing about SQLX is it's got all of the base golang SQL library completely at your fingertips, so you can use a normal exec, just as simple as this. So we are simply going to come in, delete from the to-dos where the ID is or whatever we pass in. We are then going to give you, we're going to, as I say, get our database pool. We're going to do an exec with whatever ID is and pass that into this query. If we get any kind of error, we then are just going to return an error. We could have just returned the error that this comes back, but I feel like I was feeling fancy at this point. I mean, this is, if you're ever bringing something out to a front end or something that's ever going to be returned to the user, really you want to be logging the error that comes from here and actually returning your new error. That is realistically the better way to do this. We can then have a look, if we want to know about it, at how many rows were affected, meaning how many rows were deleted, and pull that out, and we can just print that and just say, this is how many rows was deleted. So let's quickly look at what to-dos we have. So we have steering the ship, commanding the crew, and manning the cannons. So that's just delete. Let's say he steered the ship and now he wants to command the crew. So let's come in and let's just have a look at deleting a record. So we won't have to worry actually about doing any logs for this because they are already in our function. So we should simply just be able to paste that in, do this, and if we get an error, that will be returned. So now, does it expect? So once that's to do number 1. Cool. Let's have a go at running this main function now. And we should see deleted rows as 1. And if we take a look back at our to-dos, we'll see that we've now only got commanding the crew and manning the cannons back. To finish up this tutorial, let's make an update function. So with this one, we're going to do it a tiny little bit different. For here, we are going to bring in this new function here called create context. This is how you can deal with timeouts within any of your requests that you want. So this just basically creates a timeout that says, if anything that's used in this context takes more than 10 seconds, kill it, stop it from doing what it's doing. You want this more when you're working with things like APIs that if it's long running and something's going wrong and it shouldn't be running for that long, using a context with there just to stop it, to stop things from just endlessly running. This is how you do that. Let's quickly take a look at this function I want to do here. We're just going to make another struct function for updating the user with a new username. So we're going to create our new context here. We make sure you cancel any context afterwards just to clean yourselves up. We'll then take in whatever the username we pass in and we will add that to the user struct so that has been updated in memory. We are then just doing a simple query again where we're going to be using a named exec for using the username that is on that struct, which is mapping correctly to our database. And we're going to look at the ID of that user as well to make sure that it is the correct user that's being updated. Really nice and clear within the query how that works using the named queries. So if we look at this function, the only thing that is slightly different to user context is that you will note that any function that is in the SQLX library also has a context version that is simply putting context on the end. You just pass in the context and this is now a timeoutable function. Right, so just like what we did with the function before, if there's any errors, let's return an error. We can have a look at how many rows are affected and we will just update that here. So let's head back down and we can grab where we updated a user before. Grab that, get rid of deleting the record. That's bring in this user. We can then just say, so we already have the ID of the user, so we can now then just say update with context, and let's just say he levels up to Supreme Sparkle. There we go. Or let's just do Supreme Sparkle because there's only one Supreme. Okay, run that, and that should then give us an updated one row. If we take a look in our database, we will now see that Captain Sparkles, as it was before, is now Supreme. I believe that this is everything that you need to know. So these are the basic commands that I'm using on a daily basis. If you feel like I've missed anything, drop me a comment. I'm happy to do any updates to this video or bring out a part 2. But for me, this covers 90% of what I do on a daily basis when I'm interacting with SQL. But yeah, thank you so much for watching the video. I really hope this helped. If you've got any things that you also want to learn and you think I would be a good person to teach you on that, please drop any suggestions down below. More than happy to cover anything. I have worked in a lot of things at this point in my career, so I plan to keep putting these out now and then whenever I have been working on something recently. So yeah, drop me a line, feel free to subscribe. It'd be amazing to get any likes or whatever else. But yeah, thank you so much. I hope you have a wonderful day and have a good night. Bye.